Well, hello students, welcome back to Mathematics class with me, Mr. Alfie. In this video, we're going to learn about three diagrams. Three diagrams is used to explain a process or maybe to make a family tree diagram to track your ancestor. In mathematics, you can use it to list all the outcomes for an event. And don't forget the formula of probability that I have shared at the previous video. The formula of probability is number of favorable outcomes per number of total outcomes. If a random experiment consists of two or more processes, we can use the tree diagram to represent the sample space. Like this example, 3 unbiased coins are tossed. In this event, it involves 3 processes because it's 3 unbiased coins. So, how to make the tree diagram based on this event? We know that the possibility of the coin only head and tail. So the first coin head and tail. So the second coin is also head and tail. But we will repeat head and tail to each possibility in the first coin. For head, we get head and tail. And for the tail at the first coin, we also have head and tail. The third coin is also head and tail. So we repeat head and tail to each probability in here. So head and tail, head and tail, head and tail, and so on. So this is the outcomes. There are 8 outcomes. Head, head, head means you got head at the first coin, head at the second coin, and also head at the third coin. Head, head, head become this one. How about this one? Head, tail, tail. It means you got head at the first coin, tail at the second coin, and also tail at the third coin. Head, tail, tail. You got this one, HTT. So you can answer all the questions based on this event, like this one. Find the probability of getting 3 heads. So if you look very closely in this list of outcomes, actually there is 3 heads. So H. Since only 1 favorable outcomes and there are 8 total outcomes, so the probability is 1 per 8. The number of favorable per total outcomes. How about this one? Find the probability of getting 2 heads and 1 tail. So based on these outcomes, this is the favorable outcomes. 2 heads and 1 tail. HHT. And this one is also the favorable outcome. 2 heads and 1 tail. Head, tail, head. And also this one. Tail, head, head. THH. So there are only 3 favorable outcomes. The probability is 3 per 8. The number of favorable outcomes per number of total outcomes. How about in this event? Bag A contains 4 chips numbered 1, 3, 5, and 7 respectively. Bag B contains 3 chips numbered 2, 4, and 6 respectively. A chip is drawn at random from each bag, from bag A1 and from bag B also 1 chip. Draw a tree diagram to show all the possible outcomes. How to draw the tree diagram based on this event? We know that bag A is 1, 3, 5, and 7 and bag B is 2, 4, and 6. So we list the possibility of bag A and we repeat all the possibility of bag B in each possibility of bag A. This one, the possibility of bag A is 1, 3, 5, and 7. For 1, we list all the possibility of bag B, 2, 4, and 6. And we repeated the possibility of B in the second possibility of bag A. For 3, we repeat again 2, 4, and 6. For 5, and so on for 7. So 1, 2, it means you got the chip number 1 from the bag A and number 2 from the bag B. 1 and 2. How about this one? 3, 6. It means you got 3 at the first bag and 6 at the second bag A and bag B. So, find the probability that the sum of the 2 chips drawn is 7. So you need to add the numbers. 1 plus 2 is 3. not 7. So this is not the favorable outcomes. If you look very carefully from the outcomes, these are the only favorable outcome: 1, 6, 3, 4, and 5, 2. If you add all those numbers together, each outcomes, the sum is 7. So since there are 3 favorable outcomes and 12 total outcomes, so the probability of getting the 2 chips drawn is 7 is 3 per 12, or equal to 1 per 4. How about this question? Find the probability that the sum of the 2 chips drawn is odd. So, in order to identify whether the sum is odd or even, you need to add all the outcomes together. 1 plus 2, 1 plus 4, 1 plus 6, 3 plus 2, and so on. And these are the list of the sum of the outcomes, each outcomes. As you can see, all the numbers of the outcomes are actually odd. 3 is odd, 5 odd, 7 odd, 9, 7, 11, and 30. All those numbers are odd. So, all the outcomes is actually the favorable outcomes. So, the probability of getting 2 chips drawn is odd is 12 per 12, equal to 1. How about the probability that the sum of the 2 chips drawn is even? So, since we have found that all the sums of each outcomes is actually odd numbers, there is no such even number, so the favorable outcomes is actually 0. So the probability is 0 per 12, equal to 0. Next example. From a boy and a girl will elected to be one of the place as leader, secretary, or treasurer. Represent the sample space using the tree diagram. So, we have 2 possibility, boy and girl, and 3 possibility of place is leader, secretary, and treasurer. So let's B is boy, G is girl, L is leader, S is secretary, and T is treasurer. So, we have 2 possibility, boy and girl. For boy, we list all the possibility of places, leader, secretary, and treasurer. And we repeat it again as a girl, leader, secretary, and treasurer. This is the tree diagram from this event. Find the probability that the boy is elected as the secretary. First, we need to list all the outcomes. These are the outcomes. GS, it means the girl as a secretary. So, the problem asks boy as a secretary. If you look very carefully, you will find that only one favorable outcome from this event. BS, boys as a secretary. So the probability is actually 1 per 6. One favorable outcome per 6, the total outcomes.